What meanings do platforms have in the IT market? In the IT market, whoever has a platform becomes the ruler of the world which the platform contains. Being the ruler means to have wealth from the world, that is, take a large portion of the profits. Since the platform in current IT market has the values because it has the important characteristics such as policies, dependencies, and regulation. Because of its values, each one is trying to create a platform of their own. Top-level platform containing all the platform in the computing world is the operating system. Therefore, the current operating system market has no choice but two ranges. So, how do we understand computer architecture? When we ask those who major in computer science, why do you learn computer architecture? We often get the answer such as, to get the good grade, which is a little sad reality. But those who want to be a developer or programmer must know computer architecture. If you learn the computer architecture, you get many help to understand the way in which programming language runs, what happens when you compile the source codes, or not only, you can easily understand why the errors occurred in calculations, but also we get some help to understand how to quickly execute the source codes we wrote. Let's have a look at the operating system concept and structure. As we all know that the operating system efficiently manages and operates the resources of a computer system, for example, various hardware or programs, it is one of the system programs to be easy to use the computer for users and acts as an interface role between the computer and the user. In other words, the operating system is to give us or users the usage of a computer convenience and efficiency. It largely has two purposes. It is useless that the user doesn't feel the convenience no matter how good the system performance is. And then I told it provides efficiency. The efficiency will be reduced due to poor system performance by the system overloading, as user convenience aspect is overly considered. Let's continue to look at the structure of the operating system. The operating system is largely composed of a control program and processing program. And the control program includes the monitoring programs, task management program, and a data management program. This monitoring program is the core program of the operating system and monitors the operating status of systems and the execution steps of programs. A task manager program is a program that automatically performs another task after task processing and manages preparation, processing completion, scheduling, and system resource allocation. Data management program is a program which manages processing by standardizing the data and file handling in the system, and it manages data transfer between storage units, file operation, and processing, and the logical connection between input-output data and the programs. Next is the processing program that includes a language translation program, the service program, and troubleshooting program. In case of the language translation program, it has the function to translate the source program a user has written into machine language that the computer can understand, and it includes assemblers, compilers, and interpreters. The service program has the function in which that it provides the program with high frequency of use to the user by which a system provider writes in advance. It includes link edit, sort merge, utilities, libraries, and etc. Finally, the troubleshooting program is the program for business processing of users. It is referred that frequently used programs are stored in the library and used whenever the loading needed. Let's have a look at the performance criteria of the operating system next. The operating system is largely evaluated by 4 criteria, such as throughput, turnaround time, availability, and reliability, depending on how to faithfully implement the performance. The throughput means the amount of work for processing within the unit time. The turnaround time means the elapsed time from things submitted to get it. Of course, the shorter time is considered as a good performance. The availability means the degree of ready to use when the use of the system is needed. The reliability refers to the extent to accurately solve a given problem. Now this time, let's look at the behavior and practices of the operating systems. When the application is accessed to the hardware, the operation systems coordinate requests for the hardware to make sure the application is available via an API. In other words, when an application accesses the hardware, the features provided by the operating system must be utilized. In the case of multitask operating system, it is necessary to have a job for switching CPU operation that are looked simultaneously running several applications. So it is referred to as process management, which properly splits the CPU time for applications. In addition, it is also necessary to have a structure to prevent interference by other applications in the memory area currently being used. Such operating system task is called memory management. And it also needs access management to external storage devices. So operating systems centrally manage the disk area and cover data by a file. The application cannot write to the disk area indulgently. This task is called file management. Now, this time, let me explain the operating principles of computer architecture. The figure shows the basic structure of the computer systems. If you look at these components in detail, first, there is a central processing unit called CPU. The CPU fetches instructions sequentially from the memory, and it is responsible for the functions of decoding and execution. To perform these functions, the CPU consists of several components. A CPU consists of arithmetic operation called ALU and CU. ALU performs arithmetic and logical operations. Register is also a temporary storage place of the high-speed data processing. Then the control unit called CU decodes the instructions and generates control signals for executing it in sequence. The second is the memory unit. It performs the data storage function. In order to process data by computer systems, the CPU stores the result back to memory after fetching and executing the instructions and data stored in the main memory. Thirdly, there are I/O units. I/O units are connected to the system bus, CPU, and memory units. You can see that multiple devices are connected to a single computer system, as you can see in the picture above. For example, there are disk drives, displays, a printer, and etc. Finally, the system bus serves the data transmission to connect all the components on the computer system above. In the process of the operating system, it refers to a state in which the program is executed and consists of the code, a stack, and data. Also, it contains the process control block, PCB, and is the program stored in actual memory unit. It usually means a user program or the system program to be processed by the processor. It requires a variety of resources needed, and the procedure is being active. The structure of the process, such as screen, consists of code area where the memory region placed with the commands, data area where a global variable or static variable are assigned, heap area where exists for dynamic allocation, stack area where exists for the storage of local variables, and the storage of parameters passed when the function is called. In addition, a process control block which stores information of the process is also an important component. Now, the process management is very important. Let me explain how the process status in the CPU is changed and manages the process. You can see the picture has 5 states. Each of the state is transitioned. For example, when the new state transits to the ready state, a newly created process transit to ready state after they approved. Newly created processes are ready in job queue, which has new process in order, and proceed to ready state after approved in the order. The next state transition is the step of transition to running state from the ready state. In this transition step, process that was prepared at the beginning of the ready list takes CPU, forced to transit the CPU occupant process to a ready state, and select another process by scheduling, transit into run state. Third state transition is the transition to waiting state from running state. It is considered as waiting state transition for I/O or event handling. In case of which the process of run state requires I/O operations or wait other events occurred, it is the step that the CPU were occupied by process returns itself and transit to waiting state. It is also called pending. The process transited to waiting state are waiting in wait queue. If waiting state transits to ready state, when waiting events such as I/O, job termination are occurred, it is the process transit to the ready state from the pending state. This state is also called wake up. Next step transition is the step of state transition to ready state from running state. If the process is not complete, all the work within allocated CPU occupancy time, it is referred to time runout. It is the transition state that should be placed in the ready state forced by the scheduler because of the time interrupt activated. Or by unexpected incidents during the process handling occurred, it is also the state transition that occurs when it suspends the running program and runs another program. The process transit to a ready state are usually also waiting for the order back to the ready queue. Finally, it is the step of state transition to the terminated state from running state. It is the state transition occurred when all work completed within the CPU occupancy time that the process was allocated or when the process is terminated. At this time, it is the waiting state which will transit to the terminate state for recording of memory usage and processing steps, and time after the process returns all resources. What process scheduling means, the tasks that allocate various resources of systems that need when the process is created and executed to the corresponding process. These scheduling techniques are FIFO, Round Robin, SJF, SRT, and HRN. FIFO scheduling is the non-preemptive scheduling method to handle the first task entered in the waiting queue among multiple tasks. Round-robin scheduling, although its processing method is the same as FIFO, is the method that, as it allocates a uniform processing time to all tasks, each task is done within assigned hours. But if the task not done within the hours, it is reverting the task to the last order of the waiting queue with the remaining time. This is a preemptive scheduling. SJF scheduling is the method that handles the task with shortest processing time among tasks to be processed and the non-preemptive scheduling. SRT scheduling is a method that handles the tasks with the shortest time remaining among tasks to be processed, which corresponds to the preemptive scheduling. HRN scheduling is the method that handles the tasks with the earliest priority determined by the prioritization formula of each task, which corresponds to the non-preemptive scheduling. Multi-level feedback queue scheduling is the preemptive scheduling method to be used when various tasks compositively formed. The priority scheduling is the method that performs the highest priority job first after task prioritization. Aging is a technique that in case of low priority task, when the task is not completed because the waiting time becomes longer, increases its priority as long as waiting, as a way to solve such a problem. This time we will talk about virtual memory management. One of the most important of virtual memory is the management strategy for the memory unit. Key memory management techniques are largely OPT, FIFO, first in, first out, LRU, LFU, NUR, SCR, and so on. OPT is a technique to replace a page that has not been used for the longest period of time first since then. It is likely unrealistic technique to achieve. One of the most commonly used techniques is a FIFO, first in, first out. The technique is to replace the loaded page first. It is also such a technique that Bellidy's anomaly occurs. Let's look at an example and explain it. When the following reference pages are replaced to FIFO technique from the memory unit with 3-page frame page, what is the number of page faults? The reference pages are 4, 3, 4, 1, 5, 4, 3, 5. Page fault usually occurs when there is no reference page in the frame. In case of the FIFO method, the frame value entered first would be replaced first. In other words, in the given example, page fault will occur 6 times. The next technique is LRU. Least recently used is a technique to firstly replace the pages that have not been used for the longest period of time. It is the main memory that can accommodate 3 pages. Current page is all empty state. I will explain in more detail with an example. When a program requests the page number in the following order, if LRU technique is used for page replacement technique, how many page fault would occur? But the number of page frames are 3. The requested page numbers are C, D, E, B, D, E, and C. LRU will firstly replace the page that is not used for the longest period of time. So through the page fault analysis table, total 5 times of page fault occurs. The next technique is LFU. It's a technique to firstly replace the fewest number of referenced pages. The next technique is the NUR. It is a technique to firstly replace the page that has not recently used. It requires 2 hardware bit, which are reference bit and variant bit in every page. The last technique is SCR technique. It is a technique to have a reference bit like LRU, least recently used algorithm, while frames in each page maintain a FIFO, first in, first out order. The memory unit is a unit that is used when needed and memorizes all the programs and data used by the computer. This memory unit is divided into the auxiliary memory unit, the main memory unit, cache, and register according to the processing speed, purposes, and capacity. It has a hierarchical structure as shown in the screen. And as the layer is higher, the speed of the memory unit and the cost of the memory unit per bit are increasing, and has a character which the memory capacity is reduced. The hierarchical structure deploys the memory unit efficiently, and is a strategy to address the difference of CPU process speeds and I/O speeds. Let's continue to look at each memory unit in more detail. Firstly, a main memory unit is a memory unit that directly exchanges the data with central processing unit and consists of a program memory space, a task space, input data memory unit, and output data memory unit. As the main memory unit is a mass integrated with IC memory cell on semiconductor silicon plate, it has beneficial features such as a small size, fast speed, and less power consumption. And because of the ability of high-speed data processing and mass production, it is also cost-effective against performance. The main memory unit is largely divided by RAM and ROM. Next, the cache memory unit is a unit for which can copy and temporarily store some data of instructions and data stored in the main memory unit, and its data storage and retrieval speed is faster than main memory. Also, when the CPU is processing the instructions and data stored in cache memory unit, as it can be faster than the main memory unit, as a result, the cache memory unit serves to improve the processing speed of data and instructions in the CPU by reducing its difference between the main memory unit, which operates slow, and the CPU, which operates fast. For this reason, the cache memory unit is also known as high-speed buffer memory unit. In addition, although the CPU contains registers with the access speed similar to the processing speed of the CPU, these registers, as mentioned earlier, have disadvantage of difficult configuration of large capacity because of its high cost. In case of the cache memory unit with lower cost, as it is 5 to 10 times faster access speed than the main memory unit, so that it stores frequently used instructions and then provides CPU with high speed rate, CPU price is determined by capacity of cache memory unit. Lastly, auxiliary memory unit can store semi-permanent data as the unit that support the limited capacity of the main memory. It is processed after being transferred to main memory unit without giving information directly to the CPU. A magnetic tape, a magnetic disk, a floppy disk, flash memory, CD-ROM, and an optical disc are included in the auxiliary memory unit. As previously discussed, the auxiliary memory unit is positioned in the lowest layer of the hierarchical structure of the memory unit. Although its operation speed is slow, the cost is cheaper and large amount of data can be stored. Connectors of the auxiliary memory unit are an IDE method that connects to IDE parallel interface using a parallel cable and a SATA method that connects using the serial connection with a relatively high speed. In addition, the auxiliary memory unit is classified according to the access method and the size of the computer. Firstly, the access method is divided into a serial access method and a direct access method. Each method is classified with a magnetic tape and cassette tape, hard disk, floppy disk, CD-ROM, and DVD. And in accordance with on the size of the computer, it is classified into the auxiliary memory unit of medium and large computer and auxiliary memory unit of personal computer. There are respectively a magnetic tape device, magnetic disk device, magnetic drum device, magnetic card device, a hard disk, a floppy disk, CD-ROM, DVD, CD-RW, and SSD.